Hi everyone, welcome to this GCSE Higher Revision video. There's 75 days to go into your GCSE Maths exam, and today we're going to be focused on the second part of the histogram lesson, so the reading histograms. So if you got the revision card number 41 is the reading histograms revision card, so hopefully that'll be useful for you as well. So in this video, we're going to focus on questions that involve reading histograms. So I'll talk about how to approach them. I'll give you some questions to try yourself. And then also you can then maybe finish off the histogram practice questions that you perhaps started yesterday. So let's get started.
Okay, so today we're going to be looking at reading histograms. So we looked yesterday at drawn histograms, and we looked at the fact that frequency density was frequency divided by Collatz width. Now if we rearrange that, we'll get the frequency is equal to frequency density times Collatz width. So here we've got a histogram, and we can actually use this, the fact that frequency is equal to frequency density times Collatz width, to find the frequency of each of these categories. So in terms of this table, we've got the time and the frequencies, and we've got the time between 0 and 10 seconds, between 10 and 15, between 15 and 17.5, and we know the frequencies there is 10. We've got between 17.5 and 22.5 seconds, and between 22.5 and 30 seconds. And again, we know the frequency there is equal to 15. Let's look at the two that have been done for us. So if we have a look at this one, between 15 and 17.5. So between 15 and 17.5, so the Collatz width there would be 2.5, because it's 2.5 wide. The frequency density of that bar is 4, and 4 multiplied by 2.5, the frequency density times the Collatz width, 4 times 2.5 would be 10. And as you can see, the frequency there is 10. Now, in terms of this bar, we've got from 22.5 to 30, so the Collatz width is 7.5, and we've got the frequency density is 2. So if we do 2 multiplied by 7.5, the frequency density times the Collatz width, we'll get that's equal to 15. And again, the frequency is equal to 15 there. So we can now use this, the fact that frequency is equal to frequency density times Collatz width, to find these missing frequencies. So in terms of the first bar, we've got from 0 to 10, so the Collatz width there is 10, it's 10 wide. The frequency density would be, well, let's check here, that's 1.1, 1.2. So if we do 1.2 times 10, that's equal to 12. So that means the frequency here would be 12. So that's 12, fantastic. Next, between 10 and 15, so between 10 and 15, the Collatz width is 5. The frequency density would be 2.2. So if we do 5 times 2.2, that's equal to 11. So the frequency for this bar would be 11. And finally, for this bar here, this 17.5 to 22.5, the Collatz width is 5, it's 5 wide. The frequency density, we've got 2.5, 2.6, so it's 2.6. So if we do 5 multiplied by 2.6, that's equal to 13. So that means the frequency for that bar would be 13. So we found the frequency for each of these categories, and that's it. So using frequency density times Collatz width will help us find the frequencies. Okay, so let's have a look at a question now for you to try yourself. So we've got this histogram, and it represents the distances that 565 students travel to school. So 565 students travel to school, and this histogram shows us that some travel between 0 and 10 kilometers, some between 10 and 15, some between 15 and 20, and some between 20 and 30. And I would like you to find these frequencies, to find these missing frequencies. Okay, so pause this video and do that now. Okay, so in terms of these bars, let's start off with the first bar. It's got a Collatz width of 10, because from 0 to 10, it's got a Collatz width of 10. It's 10 wide, the category. It's got a frequency density of 15. So if we do 10 times 15, that's equal to 150. So the frequency for this bar would be 150, this category, 150. The next category, it's got a Collatz width of 5. So it's got a Collatz width of 5. And then we're going to multiply by its frequency density. So that would be 28. And 5 times 28 would be 140. So this category got a frequency of 140. Next, between 15 and 20, it's got a Collatz width of 5. Its frequency density is 35, so if we do 5 multiplied by 35, that's equal to 175. So that category's got a frequency of 175. And finally, the last category, it's got a Collatz width of 10, because from 20 to 30, the Collatz width is 10. Its frequency density is 10, so 10 times 10 is equal to 100. So its frequency is 100. And we can check this. If we add these frequencies up, we should get 565. So 150 plus 140 plus 175 plus 100 is equal to 565. Perfect. And that's it. Okay, so let's have a look at another question. So this time we've been given a histogram, and it shows information about the time taken by a group of students to answer a question. So they're given a question, and this shows information about how long it takes them. And we're told that 15 students took longer than 22.5 seconds. Let's just check that. We've got this bar here, it's 22.5 seconds. So from 22.5 to 30, it's got a Collatz width of 7.5. Its frequency density is 2, and 7.5 times times 2 is 15, so that would be 15 students. Perfect. Okay, so the question says, what fraction of the students took less than 10 seconds? So what fraction of the students took less than 10 seconds? Now, in terms of this question, I would probably want to find out how many students there are altogether to begin with, because the question doesn't actually tell us how many students there are altogether. So let's find out how many students are altogether. Now, for this bar, we know the frequency is 15, because we were told that in the question. Let's find the frequencies for the other bars. So let's look at this bar. It's got a class width of 10. Its frequency density is 1.2. 1.2 multiplied by 10 is equal to 12. So the frequency for this bar is 12. Now let's have a look at this bar here. Its class width is 5. Its frequency density is 2.2. 2.2 times 5 is equal to 11. So its frequency is equal to 11. Our next bar, it's got a class width of 2.5 because this is 17.5 in the middle. So from 15 to 17.5 will be 2.5. It's got a frequency density of 4. So if we do 2.5 multiplied by 4, that's equal to 10. So it's got a frequency of 10. And finally, this bar here, it's got a class width of 5 because from 17.5 to 22.5, that's 5 wide. And actually, if we notice here that every time we've got 2 blocks, that's equal to 5. So 2 blocks, it's equal to 5. So it's got a class width of 5. Its frequency density, that's 2.5, that's 2.6. So we're going to do 5 times 2.6. So 2.6 multiplied by 5 is equal to 13. So it's got a frequency of 13. And if we add these up, that would tell us the total frequency. So 12 plus 11 plus 10 plus 13 plus 15 is equal to 61. So the 61 students altogether, and we're asked what fraction. Let's write that down. So when we add those all up, so add, that's equal to 61. And we're asked what fraction of the students took less than 10 seconds. So these students, these 12 took less than 10 seconds because this bar is between 0 and 10 seconds. So these 12 students took less than 10 seconds. So this is what fraction of the students? Well, the 61 altogether and 12 took less than 10 seconds. And the answer would be 12 over 61. And let's just check that doesn't cancel down. No, that's it. So 12 over 61, that's the fraction of students that took less than 10 seconds. Okay, let's have a look at our next part. So our next part is the same histogram. If we look back, we've got the same histogram. And this time we've been asked to estimate how many students took between 5 and 15 seconds to answer the question. Now, this question says estimate because if we have a look at this histogram, we know how many took between 10 and 15 seconds. If we go back between 10 and 15 seconds, we know there was 11 there. There's 11 in here. And we can check that. The class width is 5. The frequency density is 2.2 and 5 times 2.2 is equal to 11. So we know 11 students took between 10 and 15 seconds. We know that. But the question is estimate because if we consider between 5 and 10 seconds, this part here, because obviously we want between 5 and 15 seconds, we're going to need to know how many people are in here. But we can't actually work this out exactly because we don't know how these values lie in between 0 and 10 seconds. All these students may have taken 1 second. They might have all taken 9 seconds. We're not entirely sure. But what we're going to assume is that half of them took more than 5 seconds and half of them took less than 5 seconds. So what we're going to do is we're just going to look at this region here. So for this region here, the class width is 5. Between 5 and 10, the class width is 5. The frequency density is 1.2. So if we do 5 multiplied by 1.2, that's equal to 6. So that's going to be 6 in there. And if you think back, we had 12 for the whole thing. So half of that would be 6. And what I done was I just worked out the class width for the bit we wanted, this strip here. And we done 5 multiplied by 1.2 is equal to 6. So 6 there and 11 there. So altogether there'll be 6 plus 11 is equal to 17. Our estimate would be 17 students. And that's it. Okay, now in terms of reading histograms, sometimes we're asked to find an estimate for the median or lower quartile or upper quartile or interquartile range and things like that. Now in terms of finding an estimate of the median from a histogram, one approach would be to find exactly where, if you were to draw a line down in the histogram, where you would draw that line. So half of the squares would be to the left of it and where half of the squares would be to the right of it. So that's one approach in terms of finding an estimate of the median. Now in terms of finding an estimate for the median height, what I tend to do is I tend to use an approach called linear interpolation. Now strictly speaking, you don't need to know this approach for GCSE maths, but it can just make it a lot easier, particularly if this line is, you know, like 7.5 squares and so on, and it gets a bit sort of trickier. Linear interpolation will just help you work it out quickly and easily. So linear interpolation is this. You would use lower bound plus number into category over number in category times the class width. So it's the lower bound plus the number into the category divided by the number in the category. So in other words, the fraction into the category times the class width. And if you work that out, that'll tell you your estimate for your median or your lower quartile, your upper quartile, and so on. So it's the lower bound plus the fraction into the category times the class width. Okay, so I'm going to show you how I would do this for a question like this. Okay, so I'm going to get rid of that for the minute, and I'm just going to show you how I would find an estimate of the median using this histogram. So what I would do is, if I want to find an estimate for the median from this histogram, I would find the frequencies for each of the categories to begin with. So I've just jotted down a quick group frequency table here, where I've got from 0 to 75, from 75 to 125, from 125 to 150, and from 150 to 250. And in terms of our frequencies, we're going to do 75 times 8, so that's equal to 600. We're going to do 50, the class width multiplied by 16, so 50 times 16, that's equal to 800. We're going to do 25 times 20, so 25 times 20 is equal to 500. And then finally 100 multiplied by, well, what's the frequency density here? We've got 4, we've got 6, that's 5. So it's 100 times 5, that's 500. And let's just check this. If we do 600 plus 800 plus 500 plus 500, that's equal to 2,400. So that's equal to 2,400 altogether. Fantastic. Now, in terms of finding our estimate for the median, first of all, let's find the position of the median. And there's 2,400 trees. Let's find the position of the median to begin with. Because it's group data, we can just divide that by 2. So 2,400 divided by 2 is the 1,200th tree. So that means we're going to be looking for the 1,200th tree. So is the 1,200th tree in here? No, we've only got 600, so it's not in there. Is the 1,200th tree in here? Yes, because we've got 600 and another 800 will be 1,400. So that means that our median tree would be in here. Okay, so now what we're going to do is we're going to use linear interpolation. So that is the lower bound plus the number into that category over the number in category times the class width. Okay, so in terms of this category, well, the lower bound is 75, so lower bound is 75 plus the number into the category. Well, we're looking for the 1,200th tree. Well, we've gone 600 so far. Well, we need to go another 600. So we need to go 600 into the category. So 600 into the category over the number in the category. Well, there's 800 in that category, and times the class width of that category. Well, the class width of that category is 50 because it's 50 wide, so multiply by 50. So we've got the lower bound plus the number into the category over the number in the category. So in other words, it's 3/4 of the way into that category, because 600 over 800 is 3/4. That's the fraction into the category we're looking, multiplied by the class width, which is 50. That means if we work out 75 plus 600 over 800 multiplied by 50, we get an answer of 112.5 centimeters, and that's our estimate for the median height. Now, another approach would have been to find where that line would have went, so there's exactly half to the left and half to the right. Well, because we wanted to find the median, which was the 1,200th, we know we needed to go in over 600 into this category. So there's 800 altogether in this bar. We want to go 600, that's 3/4. So we would just go 3/4 into the bar, and if you get a ruler and pencil and you go 3/4 of the way into that bar, that would be there, and then you could read off what that value was, and that line would be exactly 3/4 of the way into this group here. So we've got, if that's 100 and that's 125, that would be 112.5 centimeters. So again, that's how you'd find the position of that line. So either one of those two approaches would work. I like this approach, particularly if it's a bit trickier to find where the line was. So I just like using a linear interpolation, but if you want to use the line, that would work also. Okay, let's look at our next question. Okay, and sometimes rather than being asked to find the median, we might be asked to find the upper quartile or lower quartile and so on. So here's a question that just says find the upper quartile. So we've got the same histogram here, and what we're going to do is we're going to find the upper quartile. So I've used that group frequency table that we've done before. So we worked out all the frequencies for each of the bars, and we've got 2,400 trees. So if we wanted to estimate the upper quartile, we would work out 3/4 of this. And remember, it's an estimate, so we can just work out 3/4 of this. So dividing it by 4 would be 600, times it by 3 would be 1,800th. So we're looking for the 1,800th tree. So is the 1,800th tree in here? No. Is the 1,800th tree in here? Well, we had 600 and another 800 would be 1,400, so no. If we have another 500, that's 1,900. So would the 1,800th tree be in here? Yes, it would be. It would be in there. So we're looking for the 1,800th tree, and it's going to be in here. So again, you could draw a line, and I'll talk about that in a moment, but what I'm going to do is I'm going to use linear interpolation. So it's the lower bound plus the number into category over the number in category times the class width. So in terms of this category here, we're looking for the 1,800. So it's in this category, we know that. So the lower bound is 125 plus. Well, we had 1,400. We want 1,800. So we need to go over 400 into this category. So 400 into the category over the number in the category, which is 500. And then we just need to multiply by the class width. And the class width, how wide is that class? It's 25 wide, so 25. And if we just type this into our calculator, 125 plus 400 over 500 multiplied by 25, that's equal to 145. So that means our estimate of the upper quartile height would be 145 centimeters, and that's it. If you wanted to use the line approach, we were looking for the 1,800th tree, so we want to find where we're going to put the line so that 1,800 trees are to the left and 600 are to the right. So is it in here? No, it's going to be in here. This is 1,400. We need to go over 400 trees. So we know it's going to be in here between 125 and 150. So where are we going to put that line? And we want to go 400 trees into this category. Well, the frequency density is 20. So that means that if we know we're going to do 20 multiplied by 20, so we're going to go across 20 to here to 145. And if we go across to 145 there, then you would have if that's 145, our upper quartile is 145 centimeters. And then that would mean that you've got a class width there for that strip of 20 multiplied by 20 would be 400. So there'd be 400 trees in there, 800 trees in there, and 600 in there, and that would be 1,800, and that would work also. So that's how you'd find out that that line would go there. So you'd have 145 as the upper quartile, and that's it. So you could use either approach. You could use that line approach, or you could use the linear interpolation approach. I just like that formula. Okay, now here's a question for you to try yourself. So here's a histogram, and we're told that 120 students were late to school, and the histogram shows information about how many minutes they were late. And the question says estimate the median time late. So feel free to pause the video and to work that out. Okay, so the question says find and estimate the median time late. So in terms of this, let's jot down our frequency tables. Okay, so we've got our minutes late between 0 and 2, between 2 and 4, between 4 and 7, and 7 and 12. And let's jot down our frequencies. Between 0 and 2, well, the class width is 2. The frequency density is 17.5. 2 multiplied by 17.5 would be equal to 35. So that has a frequency of 35. Next, between 2 and 4, the class width is 2. The frequency density is 15. 2 times 15 is equal to 30. So that's 30. We don't actually need to go any further at this point, actually, because we're looking for, in this question, is 120 students. We're going to be looking for 120 over 2 is equal to 60th student. So we're looking for the 60th student. I remember it's an estimate, so we can just divide by 2. So we're looking for the 60th student. So we could just stop at this point. But just to finish off, we've got the class width here is equal to 3 from 4 to 7. The frequency density is 10. 3 times 10 is equal to 30, so it would have a frequency of 30. And finally, between 7 and 12, it's got a class width of 5. The frequency density is 5. 5 times 5 is 25. And if we add those up, we get 120. Okay, so we've got our group frequency table. Now, we could try and find where that line would go, but I'm just going to use linear interpolation in this question. So I'm going to go for the lower bound plus the number into category over the number in category times the class width. So in terms of this, well, let's find where the 60th value is. Is the 60th person in here? No, they're not. Is the 60th person in here? Yes, they are, because we've got 35 plus another 30 would be 65. So the 60th person's in here. So in terms of this category, the lower bound, well, the lower bound would be 2 plus the number into the category. So we've gone 35. We want to get to the 60th, so we need to go over 25. So it's 25 into that category over the number in that category, which is 30. Multiply by the class width of that category, which is 2. So just to recap, the lower bound is 2. In terms of the number into the category, well, we've gone 35. We need to go over 25 to get to the 60th one. So it's 25 into that category. The number in the category is 30. And then the class width is 2. And if we just work this out, it'll tell us our estimate for the median time late. So let's work that out. And that would be equal to 3.6 reoccurring minutes. Or if we want to round that to 2 decimal places, that'll be 3.67 minutes. The 2 decimal places, and that's it. And if you got that, well done. Okay, let's have a look at one last question. I would highly recommend after doing this question, you go to the Corbettmaths practice questions and you try the practice questions, because I've got some more questions like this on there for you to try. So we've got a histogram and we're told that 24 cars traveled faster than 40 miles an hour. So there's 24 cars traveling faster than 40 miles an hour. So that means that there's 24 cars in there, 24 cars. And we've been asked to estimate the number of cars traveling between 25 and 35 miles per hour. So between 25 and 35 miles per hour. And we've been asked to find out an estimate for how many cars are travelling between 25 and 35 miles per hour. Now, with a question like this, there's a few different approaches you could use, and I'm going to go through a couple of them now. Okay, so in terms of this, one approach you could do is, well, there's 24 cars traveling more than 40 miles per hour. So we know that in this bar that this represents 24 cars. And if we look at these blocks here, we've got 1, 2, 3, 4, 5, 6 blocks. And that means that if we share the 24 cars out equally between these 6 blocks, each block would be worth 4. 4, 4, 4, 4, 4, 4. And 6 times 4 is equal to 24. So that means that each block is worth 4. So that means if we look at 25 to 35, we can see how many of those blocks there are. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means there's 12 blocks, each one containing 4. So 12 times 4 is equal to 48. So our estimate would be there'd be 48 cars traveling between 25 and 35 miles per hour. That's our estimate. So that's one approach you could use in a question like this. Now, this one was quite a nice one where actually it worked out really nicely. Sometimes you'll find that it actually doesn't fit in evenly, or it doesn't fit in perfectly like that. So I'm going to show you another approach you could do in a question like this. And this approach would be quite handy whenever it's not just as nice as just counting the number of blocks. So what I would do here in this question is I would find out how many little small squares there are. So let's look at this bar here between 40 and 50, and let's see how many little small squares there are. So if we look at it going across, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little squares going across. And in terms of going up, we've got 5, 10, 15. So that means that we've got 10 multiplied by 15 is equal to 150 squares. So that means there's 150 of the tiny squares in this bar. And that we know that 24 cars is equal to 150 squares on this diagram. So that means that if we divide by 24, we can find out how many squares each car is worth. So if we divide by 24 and divide by 24, we'll find that one car is equal to 150 divided by 24 is equal to 6.25 squares. So 6.25 squares on this diagram is one car. So if we now see how many little small squares there are in between 25 and 35, we can then divide that by 6.25 to see how many cars there are. So let's do that. So in terms of between 25 and 30, we've got 1, 2, 3, 4, 5 little squares going across, and we've got 5, 10, 15, 20, 25. So we've got 25 multiplied by 5, 125. So that means there's 125 little squares in this region here between 25 and 30 miles per hour. Now let's see how many squares are in here. We've got 5 going across, and then 5, 10, 15, 20, 25, 30, 35. So 35 multiplied by 5 would be 175. So that's 175 squares in here, 175 squares. So that means there's 125 squares here, and 175 squares there, and 125 plus 175 is equal to 300 squares. So that means there's 300 squares in the region where we've been asked to estimate how many cars there are. And we know that one car is 6.25 squares. So if we take the 300 and we divide that by 6.25, so 300 divided by 6.25 is equal to 48. So our estimate would be 48. This is sort of the approach that I would sometimes use in these questions, and I highly recommend going to the Corbettmaths practice questions and having a look at some questions like this.
And that's it. So in this video, we're focused on the questions that involve reading or interpreting histograms. Obviously, you've got some that are a bit easier than others. So obviously the ones that have the scales labelled are a bit easier than some of the ones that don't. So obviously there's a sort of a range of difficulty there. And if you finish off the practice questions that you tried yesterday, then hopefully, and they're in the description below, hopefully that will give you even more practice to be more confident on reading and interpreting histograms. But again, I really hope you found this video useful. Just keep up the hard work. You're doing fantastically well. Watching all these videos, going through all these topics, it's really useful for your revision. You're starting early, which is one of the key things. And also, if you do stuff like your 5-a-days, and because you're doing GCSE higher, I'd recommend obviously the Foundation Plus and the higher 5-a-days. And if you're pushing for that top grade, the higher plus 5-a-days as well. So I really hope you find these videos and resources useful. Good luck with your revision. Good job on starting early. And I'll see you tomorrow at 3 o'clock. Cheers. Bye.